Hi everyone, and welcome back to Napkin Math. In today's video, I'm going to be modeling an object in OpenSCAD as part of my OpenSCAD series so that you can see how OpenSCAD can be used to solve real-world problems. So today in particular, the problem at hand is that it's going to be freezing temperatures outside soon, and so I want to move some of my plants indoors. And I also happen to have an unused grow light that came as part of a standalone hydroponic garden that I have that I'm not using right now. And I want to use that grow light for the plants that I'm moving indoors because they need light, and this grow light is all that I have. Now, as you can see from these photos, I'm actually already using it for this purpose, but I had to shove the metal arm of the grow light into the dirt of one of my planters to keep it standing upright. And that's because the grow light itself doesn't have any base. It normally would attach to the tub of the hydroponic garden that it came in, but without that tub, it's just a light on a stick, and the profile of the metal arm, which you can see in these photos, just continues down the whole way into the dirt. There's no base or anything different at the end of it. So yeah, given this problem, what I want to do is whip up a quick 3D printed base that this arm can slot into so that the grow light can stand on its own and doesn't need to rely on one of these planters or the dirt in them to keep itself upright. So with that, I'll go ahead and get into OpenSCAD so we can get to work. All right, make a new file. And so first of all, I need to save my file somewhere to make OpenSCAD happy. So I'll go ahead and save this to my desktop. That's fine. Okay, so the first thing I want to do here is I want to set up some variables at the top for the length and width of the arm. And I'll call it the insert. I guess I'll call the arm the insert here. And keep in mind that by length here, I actually mean the longer of the two measurements of the cross-section of the arm. So I've got my length and width. After this, if you noticed in the photos, the cross-section of the arm is actually rounded on both ends. So I'm going to represent that using two circles of radius insert width over 2. And it's insert width over 2 because, think about it, that's what the radius is. And what I'll want to do is, translate them until the convex hull makes the cross-section of the arm. But actually, I'm going to go ahead and switch from circle as well. So we have our circle here, but I'm going to go ahead and switch over to cylinder to go ahead and bring this thing into the third dimension. Okay. Now I'll go ahead and also put the $FN resolution parameter at the top, make it look a little better. All right. So now I'll make, set it to that. I'll set it to 24 for now. So I'll go ahead and make a second cylinder now, and then I'll start translating them so that their convex hulls form the cross-section of the arm. So to do that, what I need to do is move one cylinder a bit to the left of the center and one cylinder a bit to the right of the center, and then hold them both. So first I'll worry about moving the second cylinder here a bit to the right. And now the question is, how much along X do I need to translate it? Well, if you think about the desired end state, I want the distance from the beginning of one circle to the end of the other circle to be insert length. So to do that, I need to translate the second cylinder to the right such that its end is at insert length over 2. And since the circle itself has a radius of insert width over 2, that means I need to not just translate it by insert length over 2, but actually by insert length over 2 minus that radius of insert width over 2. So let's see, I'll go ahead and paste that in there. And just like that, my second cylinder is in the right spot. So now I'll go ahead and do the same kind of translation for my first cylinder, but instead of moving it along the positive x-axis here, I'll move it along the negative x-axis by negating the translation amount, and we're good. So next, let's hull them together to get our final cross-sectional shape. And there we have it. That's our cross section from our arm or our insert. So now that we have that, we can bump up the height of this thing to make a 3D shape representing like in full the arm of the grow light, if you will. So I'll make this variable and I'll put that as the height of the cylinders. Okay, and there we go. And now that we have this shape, we can use it to subtract out, like what I want to use this for is to subtract out a perfect little slot in which our arm can slide into. Now, of course, I could just put this into any old shape, but I'm actually going to want to make a perfectly contoured sleeve around this thing, which means I want another one of these, but slightly bigger, so that I can then subtract out this smaller shape from the bigger version of this shape. So to make that easier for myself, I'll go ahead and make this a reusable module and then, parameterize it by the length, width, and height here, and then I'll call that module to keep this shape around. So let's just finish this up. I'll name the module insert. There's my parameters. Fix my indenting. Okay, and there we go. With this, I can keep my shape, and I can also now make a second, slightly bigger shape to act as that sleeve around it. So I'll define a wall thickness. Let me just reorganize my variables here. There we go. Okay, so there's the shape I had. So now with this, I can make a second, slightly bigger shape to act as the sleeve around it. So I'm going to define a wall thickness for the sleeve, and then I'm going to increase my length and width for the larger of the two objects by twice that thickness, since there are two walls per axis here. And then I'm going to difference the two objects to get this perfectly shaped hollow tube that should be able to accept the metal arm. So length and width plus 2 times wall thickness. Let's difference these two things now to cut out the smaller shape from the bigger shape here. Okay, now we're really cooking. We have this nice tube that should act as a receptacle for the arm. So now all we need is to attach this tube to some kind of a base, and we're pretty much done then. Now, first of all, I guess I want to put some kind of a bottom on this tube so that the arm doesn't just slide entirely through it. And so to do that, I could translate the whole thing up by wall thickness amount and then add some material at the bottom to cap it off. But actually, instead of that, I could also just make the outer insert height taller and then move my inner insert that I'm subtracting up by wall thickness, and then I'll get a nice result where there is effectively a cap of wall thickness amount of material at the bottom. And with that, I can work on the base. And for that, I'm thinking I want the base to be more like a clip that hugs the desk that I'm going to try to mount this thing to. So it's going to have two faces. One that rests on top of the desk and another that hugs up against the bottom of the desks. And those two faces need to be separated by some Z amount, which I'll call desk thickness here to represent the thickness of the desk. And with that, I'll make the outer sleeve now longer by that desk thickness amount, and then also I need to add another wall thickness amount to it, since we have two faces of height wall thickness to worry about now. So let's do that, 2 times wall thickness plus desk thickness, and there we go. And alas, as we see, the inner insert slot disappeared because it needs to be translated up to account for the new height of the outer insert. And now it's back. So now we need to actually make the upper and lower faces or panels of the clip. And there's a few ways I could go about that, but I want to make a nice kind of rounded triangular panel shape And you'll see what I mean. And I mean, you could see it from the preview as well. So first I'll define a couple sizing variables like clip length, which means the size of the clip along the y-axis, and then clip width, which is like the size along the x-axis. Go ahead and do this. I'll make clip length. And I'll just set that to 100 for now, and then I'll make clip width. And I'll just set that to, I don't know, say 50 per now, I guess. Let's make it 200. Okay, so again, length is going to be along actually y here, and width is going to be along x. So I think that'll be a reasonable clip size. And now what I want is to actually use, again, cylinders and hull. And actually, before I get into that, let me go ahead and replace some of these hard-coded numbers that I have here with variables. So I'll just define like insert length, insert width, and insert height up here up top, and then I'll reuse them below since they're used multiple times, and since I'm going to want to use them in the cylinders that I'm making here in a second. So I'll go ahead and extract these out and replace them like so. What did I miss? Mad about my cylinder. Okay, so yeah, now I can go ahead and use those variables also in my cylinder definition here. So now what I want is a cylinder with a radius of really insert width over 2, which is kind of arbitrary, but more importantly, I want the height to be wall thickness because I want my panel to be wall thickness thick. I guess I could do clip thickness, but I'll do wall thickness for now. And then now what I'll do is I'll move this cylinder, to some point off in the positive y, positive x direction to set it up as like one of the vertices of my rounded triangular panel. So let me focus on that. And I guess, you know what, actually, I'm going to go ahead and add wall thickness as well to the radius of the cylinder, just so it matches the profile of the tube itself. But okay, so let's translate this thing. And the amount I want to translate this is going to be by clip width over 2, right? And then minus the radius of the thing so that the end of the circle is in fact at clip width over 2 in the x direction. So let me do clip width over 2 minus the radius. So now it ends at clip width over 2 in the x direction. So now let's clone this thing and make our second vertex, and this time we're going to flip the sign on the translation to get it over to the other side. Okay, so now let's push it out in the y direction by clip length, and again we'll subtract the radius so that it actually stops at clip length, and I'll do it to the second one too. Okay, there we go. And now let's get our last piece of the triangle by like stealing the outer insert object basically, and making it have a height of wall thickness. And that's like our third, this will be like our third vertex. It's not really a proper point or cylinder, but you get the idea. So let's make this wall thickness height instead. So that way it's like the same height and it can be part of our panel when we hull it all. And again, it kind of acts like a third vertex here, but it'll perfectly mesh now with the tube itself. So now if we hold this, we get this nice rounded panel that will line up perfectly with our tube. Indent. And there we go, just like that. Now we can put our tube back here. And ta-da, it's all coming together, huh? So we got our first panel. Now we just need our second panel, which is the same as our first panel, but gonna be, translated up along Z. So to do that, let's make the panel a module, and we'll call it, I don't know, clip. What are we going to call it? Clip plane, I guess. Like that. And then we'll dump that in there like that. So now we can easily create a second one of these things. And so now we can just go add our parameters into clip plane. What else have we got? We got height. We've got a wall thickness, right? Let's see. Yeah, we got height. We got a wall thickness. Clip width. Clip length. What else? What else? Seems good enough, huh? Okay. So now let's just fill that in, and let's instantiate two clip planes with, one being translated up along Z. So there's our second clip plane, and now it's translated up along Z by desk thickness. It's going to be by desk thickness plus wall thickness, right? Let's get desk thickness. There we go. So if we just did desk thickness, right, then the gap between the two is actually not enough because the first panel has wall thickness height. So we need to add wall thickness so that way the gap itself is of size desk thickness. And there we have it. That's looking pretty good, right? All right, so now that we have this shape, I just want to make some adjustments to the variables to align with my latest measurements of things. So I'll make desk thickness a little different, and I also want the clips to be bigger, so I'll do that. Okay, so desk thickness will get, like 0.1 of extra tolerance, and let's go ahead and increase clip width and clip length here. Okay, so I think that's good. Now, I'm also worried that we need some kind of additional structural support between the tube and the top panel at this point. And so what I want to do is add like a triangular piece connecting the top panel to the tube. And there's a few ways one might go about crafting that triangular piece. But what I want to do is use the polygon primitive to make a 2D triangle and then like linear extrude it to have that thickness of wall thickness, and then we'll like translate it into place after that. Okay, so let's define some variables to describe this triangular piece. It'll have length and it'll have height. And I guess for the purpose of us focusing on this piece, let's go ahead and comment out like all this other stuff for the time being. Okay, so now let's use the polygon primitive to make this thing. So the first point in our polygon will be, at the origin, let's say, and then the next one can be at support length along X, but 0 along Y. And then the last one can be at support length along X and support height along Y. Like, support height in there, like that. So there we go. But actually, I want the opposite side to be hugging the y-axis, so let's update these last 2 points to make that happen. So let's do 0 to support height, and then like that. And there we go. So let's linear extrude it by the thickness amount. And now we just need to rotate and translate this thing accordingly. So let's rotate it. Now I always have to play a little guessing game with rotation. So let's see, yeah, like 90 degrees there, along Z to get it there, and then, okay, so it's not actually Y because of the way that the rotation order is. So let's just move over to X. I think 90 degrees along X will probably do it. Yep, there we go. Now we have that. Now we can translate it. And I think the first thing we can do is center this along X by moving it support thickness over 2 along X, right? To like get the center aligned with that Y axis. So let's grab support thickness. Okay, that's the wrong direction. So let's negate it. Okay, now we can bring back our main object to see where we're going after that. And it looks like we'll be going in the positive y and positive z by some amount. And we can reason through the amount in a second. So on y, we want it to meet up with our tube, which ends at insert width over 2 plus wall thickness, right? That's our tube. Let's go ahead and do that. Nope, not 10. So let's grab our insert width over 2 plus wall thickness from up there and plop it there. And to check that, I'll fudge around with it a little bit. So let's bring back in our main tube. And now I can like add a small amount to this and verify that by adding a small amount, like 0.1 here, there's still some little gap you can see there of background getting through. So this looks perfect. Like, the math checks out here. So now we can move on to Z. And for Z, we want to move it up by that desk thickness amount plus the thickness amount of those bottom 2 panels, so it rests on top of the top panel. So that's going to be what? That's going to be like 2 times the wall thickness plus the desk thickness. And there we have it. Just like that. And again, I can check my work by messing with the numbers a little. So let's go ahead and do that. Yep, that is looking good. That's exactly where we need it to be. Okay, so with that, we can appreciate our work and move on to slicing. All right, so final adjustments. Let's bump up the resolution of our circles, and then let's add a little bit of tolerance to some of these measurements, since the material might ever so slightly shrink, although I don't expect much here since I'll be using PLA plastic for this. But okay, let's go ahead and adjust these. Yeah. All right, there we have it. So let's export this thing to STL and get slicing. And okay, I have my PrusaSlicer here. Let's pop this open. Let's drag our model in. And at this point, we can go ahead and set our layer height and material and infill, and then just get slicing. So we'll set, I don't know, I can print this one quickly at draft. It's PLA, infill. So let's slice that thing up. Looking fine. Now, for this part, since it's relatively thin anyways, and this is a structural part, I'm going to actually opt for probably doing this in 100% infill. Um, and I'll probably also set like, so I guess, yeah, there's 100% infill. And as you can see, it didn't bump the time up that much. And I'll also drop it down to 1 perimeter because that makes for a stronger part when printing at 100% infill thanks to the overlapping perpendicular infill pattern. Um, and there we go. That's looking pretty good. Now, another thing I want to do before I spend all of this time and plastic printing the whole thing is verify that the metal arm is actually going to fit in the tube once I print it. And for this, I can use the slicer's cut tool to cut off just a small piece of the top of the tube. So then I can print just that. So I'm actually going to pop open a calculator to get the exact height of the object and then cut appropriately. So there's the, what else do I have in there? I think that'll be the exact height of my object there. So I can perform the cut just below that to get a thin slice. And yeah, there we go. And um, I'll only keep object A in this case, which is the top piece. Okay. Okay, there we go. And if I go ahead and slice this, you'll see that it's literally going to take 2 minutes to print it. So I'll go ahead and export that to G-code. So let me do that. Okay. And then another thing I want to do, after some thought, is I actually want to go ahead and remove the bottom clip from this thing entirely and just be left with that top panel to act as like a normal flat base that can sit on a desk. So I'm going to go ahead and make that cut as well. Back in my calculator. So I guess I just care about the, wall thickness plus desk thickness there. So let's go back into my cut tool. Set it just so. Keep object A just like last time, and we can see it's going to be a good cut. And there we go. Now I have this nice base, and I don't need to worry about supports or anything like that. So yeah, let's export this, and we can go over to the printer now. All right, and just like that, we have this beautiful little printed sliver. So now I'm gonna go ahead and try putting it on the arm here. And there we go. Looks like it is going to fit just fine on that thing. So now I feel confident sending the bigger print, knowing that it's almost certainly gonna fit. All right, so let's put this back and head on back to the printer to print out the full object this time. And there we go. We have a printed part, fresh off the build plate. I think it came out pretty good, especially for 0.3 millimeter layer height and the draft print speed. All right, moment of truth. Let's see if it fits onto the metal arm at this point. Give it a couple of whacks. And there we go. It's all assembled, just like that. Let's see if it can actually stand up on its own. I'm going to put it on the window ledge over here for now. Look at that. It stands all by itself. No problem. What used to just be a light on a stick is now a light on a stick with a base, such that it can stand on its own. All right, so here's the finished slash installed product here. So I just, put it on the desk and kind of tucked the base under a couple of my planters here. So it's like extra stable because it's got a little bit of weight pressing down on it too. And now I don't need to worry about this grow light falling over at the slightest gust of wind. And that brings us to the end of the video. I hope you enjoyed following along and hope you learned something. As always, like and subscribe if you liked what you saw, and I'll see you all next time.